Let's look at number 12. Number 12 says, based on Appendix E, which I believe is the standard reduction potential table, which of the following of these is the strongest oxidizing agent, and which is the weakest? So you remember that an oxidizing agent is, if it's going to be really strong, it'll be something that is reduced really easily. So we're in our reduction potential table. Let's see if we can figure out the answer to at least a couple of these. So here it is. I'll bring it over, make it a little bit bigger. Now I can't fit it all on the screen, so we're only going to look at a couple that I noticed did fit on the screen, which is this one and that one. So the dichromate one, which is right here, you notice it's written as a reduction, and the oxygen one is right underneath it. It is also written as a reduction. And they're both in acidic medium. We see the H plus there and the H plus there. So remember, the one with the higher E value, the more positive E value, is the one that gets reduced easier. So this one is definitely a stronger oxidizing agent than oxygen. So at least we can order those two. Now you need to go in and look at the other two in this table and see where they're at. But the more positive it is, the more easily it's reduced, the stronger the oxidizing agent. Now in the second part, B, they want to know which is the strongest reducing agent. So that's something that gets oxidized very easily. So when we're looking at our table, it's going to be a sort of a different situation. And I don't really see any of the ones that I've got in my example here on there. But essentially the idea is, of course, if we want something that's a strong reducing agent and it's going to be easily oxidized, well, if it's going to be easily oxidized, it's not going to be reduced very easily. So we're going to be looking for things at the very bottom. The very bottom of the table are the strongest reducing agents because they get oxidized easily. So for these, you're going to need to find the one at the bottom of the table. Now, of course, when you're doing this, the lesson isn't to remember, higher on the table or lower on the table. You got to think your way through it. These are all drawn as reductions. And so if something's going to be a strong reducing agent, it means it's going to be easily oxidized. If it's easily oxidized, it will be poorly reduced. So it should have even a negative cell potential value.